Alrighty, hello. Today we're going to be taking a look at the trends of the periodic table, just a little bit vaguely, so it's not going to be super in-depth, but you will need to know where different things are located on the periodic table, and especially know what the trends of electronegativity, atomic radius, and ionization are. You're going to be using this information that we learned today on a project in another video, so make sure you pay attention closely, take some good notes, because you will need this information for our upcoming project. So, the periodic table. The periodic table was developed by a man named Dmitri Mendeleev. He was the one that made the periodic table look the way it does today. He classified the elements in order of increasing atomic weight, which you already know. We know that the atomic weight is the number of protons in an element. We learned that last unit before break. Okay, so he arranged them as hydrogen coming first because it has an atomic mass or atomic weight of 1. He then arranged lithium, and then beryllium, and boron, and carbon, and nitrogen, oxygen, and fluorine. This picture here in this bottom right corner was his first periodic table. Those are just the elements we knew of at the time, so that's why he arranged them. Notice there's some blanks in there. Those blanks, he knew something had to fit in there. He knew something came between calcium and titanium, but we didn't know what yet. What's crazy is as those things were discovered, they fit perfectly on the periodic table according to his little theory he came up with by classifying them in order of increasing atomic weight. There's different things on a periodic table. There's the period versus the group. So a period is a horizontal row on the periodic table. So the period goes left and right, while a group is a vertical column that goes up and down. And that up and down group is based on the organization of the outer shell electrons, which we talked about last class when we talked about valence shell electrons. So those groups are arranged by their valence shell electrons. And as you already know, the entire periodic table is arranged by order of increasing atomic number, or its number of protons. Okay, so you can see here we have period 1 is hydrogen and helium. Period 2 is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Remember, you will still need to know these symbol names. So then period 3 is so on here, and then period 4 is here. Group 1 goes down and starts with hydrogen to lithium to sodium, potassium, rubidium, cesium, and francium. Okay, and group 2 is the next one. Notice we skip this middle block. We're going to come back to that in a little bit, but group 3 then is over here, followed by 4, 5, 6, 7, and group 0. Okay, this is called group 0 because they technically have 0 valence electrons because they have a full outer shell, which is going to be important to know. So, group names. Let me move my little face here. Group names. Each of the groups are organized in a different way. So these are the names of all the groups on the periodic table. The alkali metals, the alkali earth metals, the lanthanides, actinides, transition metals, metalloids, nonmetals, halogens, and noble gases. I'm going to quickly go through those with you. I have not yet decided if you need to know the names of all of them, but you do need to know like their properties and just kind of know like a little tidbit about them. Okay. So the first group we're going to talk about is the alkali metals. The alkali metals is this first group here. What I would suggest for taking notes on this is I have attached a blank periodic table that you can use to like shade in these in a different color if you choose to print out that blank periodic table. Otherwise, you do have your periodic table that I provided you with at the beginning of the year. You can write directly on that and label these on your table as well. So again, group 1 is the alkali metals. They have very reactive. Okay, they have 1 electron in the outer shell. They want to get rid of that electron, so they are crazy reactive. Group 2 is the alkali earth metals, so very similar to the alkali metals, but the alkali earth metals, they're also very, very reactive. Group 1 and 2 are very similar. The only difference is that group 1 has 1 electron in their outer shell, and group 2 has 2 electrons, valence electrons. The lanthanides. The lanthanides are down in this block down here, okay? What happens with this periodic table is see how there's these breaks right here? Okay, I hope you can see my mouse in these videos. These breaks right here. What happens is this block is taken from these 2 breaks. Okay, so this gets inserted right here. So this first top block is called the lanthanides, and they react strongly with oxygen and form oxides. Okay, and then that group below them is called the actinides. All of the things in this lower block are all very radioactive. Okay, we generally won't do much with them in class. They're very dangerous elements. The next group we're going to look at is the final group over here next to the noble gases. It's called the halogens. They're also very reactive. So notice that the first, the second, and the seventh group here are very reactive. The noble gases, you will need to know the name of this group. They're the final column on the right, the furthest right. They are super stable. They rarely react with anything. They are the perfect elements. Okay, those are our noble gases. And then transition metals are everything in the middle. Okay, they're good conductors of heat. They're just metals that can be used for other things. Okay, they're called transition metals. If we're ever dealing with valence electrons or anything with transition metals, don't worry about them. Okay, when looking at the whole periodic table, when you look at your periodic table, you can see there's a little stepping ladder down the middle. Anything that's touching those stepping ladders are what are called metalloids, okay? They look like metals, but they behave like nonmetals, okay? They're good conductors of electricity. They're neither a metal or a nonmetal. They're just in the middle of the two. And then the rest of the periodic table is divided into metals and nonmetals. So all of our nonmetals are on the right side, where our metals are on the left. And an easy way to remember that is when you think of carbon, is that a metal? No. But when you think of zinc and magnesium and aluminum, those are all metals, so you know they're to the left. Okay, and you know that nonmetals are poor conductors of electricity, and that metals are good conductors of electricity. So just like kind of a recap of what I just said, metals are to the left of the staircase. They're over here. They're good conductors of electricity, and they really get rid of their electrons easily. Okay, that's going to be important to remember moving forward. Okay, we haven't learned that yet, but it'll be helpful to you in our coming lessons that metals lose the electrons easily. Metalloids, like I said, are on that middle staircase and are shown in yellow here. They kind of conduct electricity, but not super great. And they have some properties of metals and some of nonmetals. And then nonmetals are to the right in the blue. They're very brittle and they don't conduct heat well. Notice that hydrogen is a nonmetal. It's just in a wonky spot. So remember that. All right, this is where things get important. There is a spot for this in your note packet. Notice that there's like a spot for a definition and then a spot for a drawing. Okay, so I'm going to show you what to draw. So the atomic radius. A radius is a distance from one side to another. So a radius is the distance of the center of the nucleus to the outer ring. I'll draw you a little picture here. So you know that when we draw our nucleus, we have our nucleus in the center. Okay, and then around our nucleus, we have our orbitals that look like this. Okay, let's say we have 3 orbitals here. I'm not very good at drawing on this. Our atomic radius is our distance from here to the outer ring. Okay, notice that as we go to the left and down, our atomic radius gets bigger. So our atomic radius is largest at the bottom left of the periodic table. I want you to think, does that make sense? Yes, it does make sense because francium is technically our biggest element. It has the largest atomic radius, okay? Because francium is going to be bigger than nitrogen. It's going to have more rings than nitrogen. So as we go this way and this way, our atomic radius increases. That's the type of picture I want you to draw in that box on your note sheet. Draw an arrow that goes to the left and down, showing that as we move left and down, the atomic radius gets bigger. Our next definition we're going to talk about is the ionization energy. Notice the ionization energy is opposite of the atomic radius. So ionization energy is the amount of energy it takes to remove an electron. Okay, so notice as we go up and to the right, our energy gets stronger. These elements up here are very, very, very strong. Remember how I said that metals or nonmetals generally get rid of their electrons or generally hold on to their electrons while nonmetals get rid of them, or metals get rid of them. Oh my gosh. Pretend I didn't say the last 30 seconds. Okay, metals generally get rid of their electrons while nonmetals hold on to them. that is the reason the energy is increasing from up and to the right, because these want to hold on to their electrons. They don't want to get rid of them. So they're the strongest electrons, okay? They're holding on really tight to their electrons. They don't want to get rid of them, and thus why the energy increases up and to the right. Let's try better on the next one because I really threw that apart. Lastly, we're looking at electronegativity. Notice that electronegativity also increases as we go up and to the right. Electronegativity is the ability to attract electrons, which we're going to talk about more. So atoms in this top right corner here really need extra electrons, and we're going to talk about why they need those in the next lesson. But as you increase the electronegativity, the ionization levels increase, so they're stronger and they want electrons more. So as we go up and to the right, electronegativity is going to increase. If you have questions on any of that, please let me know. Make sure you tune into your next video on our periodic table project so you know how to complete that project. Thank you.